as you can see in my screen. We will be recording this seminar, so please give your permission to that, as Núcia just asked us to do it. So as I was saying, the main theme today is OR in sustainable supply chains and supply systems. But before we start about what our awardees have to share with us, I'm just going to recall a bit, Okay, what is the Wisdom Forum? So first of all, the ones that are not involved should register themselves. So indeed, the objective here is really to have a platform, as I wrote here, to support, empower, and encourage the participation of all genders, not just women, in operation research with EURO. You can find more details in our website that is here in this slide. One thing that I want to call your attention is about this activity, the YoungWomen4OR. So we had our first call in 2020, where we selected 12 women with high potential CVs, and we already closed the one for 2021. And you see here that we had 20 applications from 13 different countries. It was very difficult to select the 12 ones, but lucky enough, we have 12 very good women that work in OR. And then on our next webinar, that will be on Monday, the 20th of December, before Christmas, Paula will share with us the awardees, and everyone will have the opportunity to meet them. Okay, for today, the awardees that we had in 2020 are here. So you see, many of them already present their works to us, but today we have essentially Iberia representation. Okay, so from Portugal and Spain, the three girls that will be with us. So we have Bruna Mota, Cátia Silva, and Jessica. The first two ones from Portugal, and the second and the third one from Spain. So we are neighbors, and they will talk about their work in this team on sustainability. Okay, sorry. Cátia will talk about design and planning of sustainable supply chain, exploring monetization strategies. Bruna will talk about what she's been doing on modeling the triple bottom line in sustainable supply chains. And Jessica will talk about restoration of drinking water in supply systems in rural areas, okay? And she will share with us a special case of Nepal. After these presentations, and I will allow 1 to 2 questions between the two presentations, we have our colleague, Grit Walther. Thank you very much, Grit, for accepting this invitation to be here and discuss with Cátia, Bruna, and Jessica their work, and also give us some thoughts about how sustainable supply chains can be in the future. So Grit Walther is a very well-known professor in operation management. She comes from Aachen. She got her PhD in 2004 at TU Braunschweig, and she holds the chair of operation management. And as you see here, her research lies in the application-oriented technico-economic model and evaluation of logistic production systems, as well as value chains. Grit did a great job, has been doing a great job in EURO, and especially I want to emphasize that she was a founder of the EURO working group in sustainable supply chain. So for that, thank you also very Grit. It was really very important to have this EURO working group working in this area. Okay, so after the speakers, 10 minutes each, as I said, the Professor Grit will give an overview, current challenges, and she will discuss with the three girls the work, and then we will have the floor open to questions, okay? So thank you very much for that. Now I will ask Cátia to start the presentation. Please go ahead, Cátia.
Okay. Let me share with you. Can you see?
Yes.
Okay. So good afternoon to all. My name is Cátia. I want to thank everyone for your presence and say that it's a great honor to be here presenting my work among so outstanding women. And today I will present part of my PhD thesis that is developed with Professor Ana Barbosa-Póvoa and Professor Ana Carvalho, entitled Design and Planning of Sustainable Supply Chain, Integrating Monetization Strategies. Okay, so I structured my presentation considering the main objective of this work and the research methodology on which it is based. Then I will present the developed decision support tool and the main outputs of this work. Okay, so as we all know, there are governmental and industrial pressures that lead companies to add to their economic focus also environmental and social concerns as well. And in a supply chain context, it is really important to also consider uncertainty and risk in the design and planning of the decisions. So as we all know, stakeholders want to improve their supply chain environmental and social performance while optimizing their economic one. And this is possible by using multi-objective optimization methods. But the main issue here is the weighting that the decision makers have to attach to those objectives. So we thought that as decision makers are used to deal with money when managing their supply chain, it would be interesting to translate the supply chain impacts into monetary units. And this will allow us to compare the economic, the environmental, and the social performances of the supply chain in the same monetary unit. So the main objective of this work is to develop an optimization-based decision support tool for the sustainable supply chain design and planning, accounting for the monetization of both environmental and social performances. So as you can see in this figure, considering sustainable supply chains, we have to take into consideration not only the economic performance, but also the environmental and the social ones. Since the economic performance is already in monetary units, we used monetization strategies to convert these environmental and social approaches into monetary units. And this allows us to integrate the three performances in the same monetary unit in an optimization model, and also to add uncertainty and risk to those three performances. We validate our decision support tool using several case studies. So regarding the economic approach, we intended to maximize the expected net present value. And to this, we consider the summing of the discounted cash flows, as well as the fixed capital investment. Regarding the environmental approach, we use the life cycle assessment methodology. This methodology includes four main phases: the goal and scope definition, the inventory analysis, the impact assessment, and interpretation. The impact assessment phase is the most critical one. Why? Because different authors can use different life cycle impact assessment methods. In my specific case, we use the EPS method, that is a monetization method, that allow us to obtain the environmental impact into monetary units by using the CIMA-PRO software. So regarding the objective of the minimization of the expected environmental impact, we considered not only the impact of transportation, but also the impact of entities' installation and production and remanufacture. Something that is important to highlight is that this parameter EI, that represents the environmental impact, is an output of the CIMA-PRO that is already translated in euros. So our main goal is to propose a mixed integer linear programming model for the design and planning of the supply chain that accounts, of course, the economic and the environmental performance and the risk assessment. And we incorporated demand uncertainty so as the results to be more reliable. Also, it's important to say that we expanded the traditional models that are based purely on economic risk to also address risk with the environmental performance. So we considered the economic and the environmental performance of the supply chain in the same monetary unit, and this allows us to aggregate both performances in the same objective function and to implement the conditional value at risk to both performances of the supply chain. This is done under demand uncertainty by using a scenario tree approach. For this, we consider the generic supply chain, where suppliers send raw materials to factories and factories send products to warehouses or directly to markets. And besides of this forward flow, we also consider the reverse flow. Our model is developed considering the possible superstructure, the entities and products involved, the transportation modes and the demand, and we obtained as outputs the suppliers, the location and the location of production facilities and warehouses, as well as the transportation network definition. So our two main objective functions are the maximization of the profit, which means the maximization of the expected net present value minus the expected environmental impact, and also the minimization of the risk, which means in this case the maximization of the conditional value at risk. For case study, we used an international supply chain that has got a factory, a warehouse, and 3 main markets, and they are wondering to expand to 3 more possible markets. As a result, we obtained a Pareto curve, and as you can see, we were able to compare both environmental and economic performances of the supply chain with the risk measure. Why? Because the 3 of them are in the same monetary units. And as expected, a high risk decision is correlated with a higher profit. Now we are working on social monetization, and for that we are studying the social indicators and how are them possible to monetize considering the design and planning of the supply chain. So to conclude, we were able to quantify both environmental and economic performances in the same unit, which can be interesting, particularly for decision makers who are used to deal with money when managing their supply chain. As main outputs of this work, I can highlight 2 papers already published in international journals. One of them that was distincted by the EURO Award for the Best Edgeor Paper 2020 review. And another publication, and another article, another paper already accepted for publication. Thank you for your attention.
Thank you very much, Cátia. You were just in time. No, we have still 0.5 seconds. Anyway, does anyone have 1 or 2 questions maximum to put to Cátia? I will give floor later on, but now is also time to clarify some aspects that you have to. Please go ahead.
Yes.
I have here, Paula, maybe you can ask the question yourself.
Thank you, Anna. Yes, Cátia, I really enjoyed that. Thank you very much. It's not really my area, so I was really interested to see how you managed to do that transformation and get a measure that you could maximize. And I was really interested to the social performance measures, and you kind of said that's going to be your future work. I just wondered what are your thoughts at a high level of how you might capture that?
Okay, thank you, Paula. Yes, we are now doing a careful literature review to understand what are the most adequate social indicators in the context of supply chains, in the context of design and planning of supply chains. And we are trying to correlating those social indicators with economic indicators in order to be able to monetize them. And we are doing, that is a paper that we are now working on. Yeah.
So I'll have to wait and read that one, I think.
Yeah.
Thank you, Cátia. I really enjoyed that. Thank you very much.
Thank you so much.
Okay, thank you very much, Paula. So maybe it's time to go now to the next speaker, Bruna Mota. Please, Bruna, can share your screen. Bruna also comes from Tecnico in Lisbon. So Bruna, please, when you are ready, go ahead.
Yeah, thank you very much also for the opportunity. So today I'm going to be presenting a work that was developed during my PhD, specifically a decision support tool that we called ToBLoOM, Triple Bottom Line Optimization Modeling. Basically this tool aims to facilitate, on the one hand, the aggregate assessment of supply chain sustainability, considering strategic and tactical decisions, and also serve as a way to optimize those decisions, taking into account environmental, economic, and social concerns. So going right into the problem, this on the left, you have here an example of a closed loop supply chain, general structure that's modeled through ToBLoOM. And this is basically to give you an idea, which you know for sure, of the complexity inherent to supply chain as is. Adding sustainability duplicates, triplicates that complexity. And basically what we have, or one of the concerns when developing this tool, was to capture the complexity in the sense of having a tool that was capable of taking into account the different decisions, the different interconnected decisions that can be taken throughout the supply chain. So for example, making a tool that was able to assess the impact of changing, for example, some product characteristics, so changing, for example, product design features, and what that impact would be in terms of transportation, warehousing, and also collection and sorting. So because again, as we are dealing with sustainability, a simple decision, as you know, can have a significant impact throughout the supply chain. So that was one of the concerns when designing this tool. Also, designing a tool that was capable of considering different stakeholders who have different decisions that will influence the supply chain, and that different stakeholders that will also be impacted by the decisions taken in the supply chain. These stakeholders in turn have multiple objectives, sometimes conflicting objectives. And on top of that, we have a lack of indicators, as Cátia was also mentioning, a lack of indicators that are capable of providing a quantitative but yet accurate or meaningful values to supply chain sustainability and the several indicators that we might be considering. To complicate that a little bit more, there's a lack of data, particularly when talking about environmental data and social data, which adds a lot of uncertainty to the problem. So these were the concerns, the challenges, and with that in mind, the ToBLoOM tool had to somehow be able to incorporate that. So it was developed to be as generic as possible, but then obviously with minor alterations so as to be easy to adequate to the different industrial contexts. So in that sense, a lot of inputs are needed. So general data such as the supply chain superstructure, capacities, and also considerations related to the collection and sorting of the end-of-life products. And then a characterization also of the economic, environmental, and social characteristics of the supply chain and the potential decisions that we were analyzing. So the main thing that I want to bring here is regarding the environmental assessment, which according to legislation and recommendations by the European Commission followed a life cycle approach, and socially, where we focused on things that the supply chain can have an impact on. So things that deciding where to locate our facilities or what type of activities to perform in our activities can have an impact on the region, for example, where we are installing these entities or these activities. So the social assessment was based on statistical data on socio-economic indicators. Outputs, of course, have to be many, so as to be able to understand those interconnected decisions that can occur. So from the supplier selection up to transportation decisions, as well as product recovery strategies. So how a specific decision can influence these types of other decisions. The outputs are characterized again in terms of the 3 pillars of sustainability, and the goal was to provide a set of solutions that would then be analyzed according to the trade-offs, as we have here, the potential trade-offs that exist in the different indicators. The methodology underlying is quite simple. It's a multi-objective mixed integer linear programming. Uncertainty was modeled using a stochastic approach, and the multi-objective component of the problem was addressed using the augmented epsilon constraint method, so as to be able to see the trade-offs of the different alternatives. I'm just going to go into a few details that I find most interesting. So one of the problems related with the life cycle assessment methodology is that it can be quite subjective, depending on the decisions taken in the goal and scope definition, as well as decisions even within CIMAPRO, as Cátia was mentioning. You can make a set of different decisions when treating your data, when collecting the data and treating the data. And so one of the concerns was looking into that and seeing how different decisions at this step could affect supply chain decisions. Another concern was related with the steps within life cycle impact assessment that we have here. And the concern was trying to include as little uncertainty as possible and as little subjectivity as possible within this life cycle impact assessment steps. So what we tried to do was to incorporate only characterization factors. Okay, so not going to the weighting part of the problem, so as to try to reduce the subjectivity involved in giving weights to the different categories. And so it was important to work with these values here at these midpoint stages, where we actually see what is the environmental mechanism behind the environmental impact that we are addressing. In terms of the social assessment, the idea, as I said before, was to work with the impact that supply chains can have in the local economy. And so our goal was to develop a model that would stimulate regional development according to socioeconomic indicators that can be quite different. And so basically we developed an objective function. In this case, we wanted to maximize the location of entities in locations where the GDP would be lower, okay, so as to stimulate the development of those regions by locating our entities or activities there. This ToBLoOM framework was applied to several case studies, considering different industries and different indicators in each of the sustainability pillars. Okay, so as to understand what would be the impact of considering different indicators. Obviously, this even in terms of the social assessment, it will be quite dependent on the case study that we are looking into, what the goals are of the different involved stakeholders. And in terms of the environmental impact, 2 different life cycle impact assessment methods were addressed according to European Commission indications. And I'm just going to share some main highlights, some main conclusions that we were able to get. So overall, ToBLoOM facilitates the prioritization of environmental intervention, considering the impact that certain activities have throughout the supply chain. It also facilitates the analysis of governmental economic incentives, particularly in the social indicator, the analysis of technological investment, and also adjusting product recovery policies to product characteristics. It also highlighted the importance of having a systems view, as I've been saying, the importance also of having a detailed understanding of the contributions of each environmental impact category. Very important is also understanding what is the robustness of the method that we are addressing, the life cycle impact assessment method. And overall, it was possible to conclude that strategies that are sometimes thought to be sustainable, if we don't consider these interconnected decisions and this global impact, it's not guaranteed that they are actually going to be more sustainable, as sustainable as we thought they would. And I really want to thank everyone for this opportunity and for having me selected. And you have here 2 works which relate to this topic. Thank you.
Thank you very much, Bruna. Very clear. Very nice picture of Lisbon. Everyone is welcome. I would like to leave the floor to 1 or 2 questions to Bruna. Please go ahead. I'm not seeing anyone here.
If I can do a quick one, Anna, if that's okay.
Yes,
again, it's because I don't know, so I'm really learning loads today. Thank you so much. Bruna, just very quickly, you mentioned transport modes somewhere within the model, and I saw within the objective function you mentioned, I think, trucks and boats. How did you capture the different transport modes and their different impacts? Was that in your scenario trees?
Yes, so the model allows selecting different transportation modes and different combinations, intermodal transportation as well, so as to perform the transportation from one continent to another. For example, you can have that multiple sequence. And so the model allows that. And what happens is that we previously characterize in the input data what is the environmental impact per ton per kilometer, for example, of each of those transportation modes. And it's selected based on that global optimum, let's say.
Thank you, Bruna.
Thank you. Okay. Thank you very much. So now we go to Jessica. Please, Jessica, Can you share your slides?
You see my screen?
Yes, thanks. Thanks, Jess, this is great. So you can go ahead.
Thank you. Good afternoon, everyone. First, I would like to thank the organizers for giving me the opportunity of being here today and share this part of my research related to the restoration of drinking water supply system in rural areas with application in Nepal. This is a young work with Professors Gilbert Laporte and Marie Francourt from HEC Montreal and Selene Silvestre from FICO. As you may remember, in 2015, Nepal was strongly hit by 2 earthquakes of magnitude greater than 7. This caused thousands of deaths and large-scale damage to buildings and infrastructures, as we can see here with this temple or in this village. In fact, most of the affected areas correspond to rural areas with difficult access. In these areas, more than 1 million people were left without access to quality water due to the destruction of the supply systems. In that sense, the Austrian Red Cross, in collaboration with the Red Cross Societies of Nepal and Switzerland, planned the rehabilitation of some damaged water supply system and was interested in developing an optimization tool to support the rehabilitation of the water supply system. Due to the hierarchy of the objectives manifested to us by the NGO and the large scale of the problem, we divide the problem into sub-problems. The water tap location allocation problem, to decide where to locate community water taps such that the people can access them according to the WASH national standards, which is the main objective of the NGO, and the water distribution network design problem, to decide how to build the network underneath, in particular, a Steiner forest network. Each of them has some important characteristic to follow. The water tap location, as I said, might satisfy the WASH national standards. These standards set the maximum distance people must walk to access the water taps from their houses. And these standards are preferably set to 150 meters horizontally and 50 meters vertically, although in exceptional cases, this can be increased up to 250 meters and 80 meters respectively. In the case of the network to build, in a mountain region as Nepal, the water distribution are usually gravity-feed systems, so no pumps are used since they are expensive and difficult to maintain for people of the region. Hence, the system must meet particular conditions for this gravity-feed system. First of all, although the pipes can go up and down, in any point in the path with the water source and the water tap can be higher than the water source. So the image on the left, we cannot have it. However, this condition is not enough. And in cases like in the right image where the water source is the highest point, we need to ensure a second condition for ensuring pressure of water. In particular, we need to verify the Hyson-Williams equation that relates the elevation of the water source, the elevation of the water tap, the distance between the 2 points, and the coefficient gamma, which is a parameter that depends on the characteristics of the pipe, like the material, the size, the roughness. To solve the problem, we have developed an efficient heuristic that exploits the hierarchical nature of the problem. Providing water in the standard is more important than the cost of the pipe. So what we do is we first solve exactly an optimization model that aims to identify the water tap locations and the household assignments by minimizing the weighted sum of the number of water taps to install and the average walking distance. And then, once the water tap locations are fixed, they are used as an input for the second subproblem, for which we propose a cluster first 3-second heuristics in order to design the Steiner forest network. In the cluster phase, we have 2 steps. First, we assign each water tap to a water source by solving a generalized assignment problem. And the second step is to identify potential Steiner vertices that can be used later to reduce the length of the network. In our problem, any point in the region may become a potential Steiner vertex. So in order to reduce the cardinality of the set of stainers for each of the cluster, we suggest 3 alternative procedures to determine which points to keep as potential stainer vertices, being the most successful the use of the Fermat point of each triangle that 3 water taps can make. In the second phase, the tree phase, what we did was we designed the network by heuristically computing a minimum stainer tree for each of the clusters separately. So first we solved the gravity minimum stainer tree model, where we are not including the stainer vertices. So we have an initial solution that will later be improved. This model is basically a classical minimum spanning tree with the requirements of the gravity fit system. That to give you an idea of how these new constraints to the model affect the difficulty of the problem, the instances, once we have clustered the water taps, we have between 3 to 80 water taps for each cluster. And this instances size would be easily solvable for the classical minimum spanning tree. However, after 1 hour of computing time, 50% of our instances are not solved to optimality, having an average gap of 40%. Then on the second step, once we have this initial solution without the stainer vertices, we propose a simulate annealing to improve the solution by in each iteration generating a neighborhood solution that randomly chooses a single stainer vertex to add or remove from the current solution. We have tested our approach on real data on 2 communities, Suspake Shimawati and Lapilang. Due to the large extension of our region, we discretize the region with a grid where each cell has a size of 25 per 25 meters, and all the information corresponding to that cell is grouped on the centroid of the cell. This data was extracted from satellite imagery with the collaboration of the CETAGIS department at Salzburg University. From here, the problem can be defined in a direct graph by associating the cells to nodes of the graph. But despite the discretization, our instances have around 29,000 of vertices and 70,000 of arcs. This is why we use this clustering method. In this table, we have the summary of the main decisions variables, the number of water taps to install, the total horizontal and vertical walking distances, and the total length of the network, based on some weight settings for the water tap location allocation model. We suggest implementing the solution given by the settings 0.25 to as the weight to the number of water taps, 0.30 as the weight to the preferred distances, and 0.45 to the exceptional distances, because these settings provide quite short distances without overly increasing the number of water taps and the total length of the network. Just as an example, in these images, you can see the location of water taps marked with the pink circles for the case where all the weight is given to the number of water taps to install, and an intermediate case where some weight is also given to the walking distances. As expected, when including the distances in the objective function, the number of water taps increase, in this case, from 88 to 111. And in this other image, we have the network solution for the village of Lapilang under the suggest weight settings. And we can see that in practice, stainer vertices, which are the red diamonds, are not used much. We have a few only in 2 of the trees. To conclude, we have developed a mathematical capable of computing quickly a solution that satisfies several technical features, the accessibility in the wash standards and the gravity fit conditions, we take advantage on the hierarchical nature of the problem that was specified by the planners. So this allowed to solve the problem through two sequential subproblems. We have implemented and tested our methodology on realistic and very large scale data sent from 2 villages of Dholaka in Nepal, and to ensure that the proposed solution accounts for the mountainous character of Nepal, we have worked with distances that incorporate elevations, adapting the Dijkstra-Shortest algorithms to three-dimensional distances. And thank you very much for your attention.
Thank you very much, Jessica. Very interesting presentation. So as before, I would ask you if someone has a question to ask to Jessica. No, but I have one in this case. Jessica, this is really interesting, but on the application, your results were used in any way, or are just really suggestions that then can be applied, or you had the lucky of seeing them applied or not?
The thing is that when they first talked to us, they wanted only to minimize the number of water taps. But then we showed them that solution, they thought that there were few water taps, and people have to walk inside the standards, but almost all the distance. So then we modified the model and add the weight, so you can play with the weight that you give to the water taps and the distances, and at the end they don't use a solution given by us, because there are also the political aspects, but they wanted the tool to see what happened and to have it as something to show and to respond her decisions with the politicians.
Okay, so a tool to inform and then to be used as let's say some pressure if possible. Yeah.
Yes, not to build exactly the solution, but that this would be measurable and we can compare, and it's only based on the region.
Okay, okay. Thank you very much, Jessica. Later on we can discuss a little bit more. So now I would pass the floor to Grit, that has some slides also to share with us, and then we will go into the discussion. Please go ahead, Grit.
Yeah, welcome everyone from my side also. Thank you very much for these nice presentations. I just want to give a short overview on sustainable supply chains and current developments, because currently there's a lot of transformation going on in our society and also in the supply chains. I think you all know about the complexity of supply chains, and Cátia and Bruna already talked about that. Here you see the supply chain of jeans, like at the first sight, a rather simple product, and you see that it is really traveling a lot. It is a complex supply chain. It is a global supply chain. We already talked about modeling the life cycle of such products. And we already talked about the economic impacts, but also the environmental and the social impacts. And we see these impacts already with rather simple products, right? And for these simple products, it might be possible to model really the complete supply chain or the complete life cycle. We've seen that. But for more complex products like a car or whatever, what we see when we look at life cycle assessment is that the manufacturers always leave out a certain part of the life cycle because they do not have enough information about the supply chain. They can model the resource supply, they can model their own manufacturing processes, but there is always a gap in between because they cannot model every single supply step in this complex supply chain. So here you see a complex manufacturer network. And you see the number of suppliers, and there's just, it is not possible really to regard for every single environmental aspects and social aspects in the supply chain. There are new methodologies, like the blockchain technology with which we try to handle this complexity. Yeah, currently we still have gaps in our data there. If we look at impacts on the supply chain, we have the scope 1, scope 2, and scope 3 emissions and impacts. Scope 1 means that impacts happening within the company itself. Scope 2 means impacts because of the bought electricity, energy supply. And scope 3 means impacts along the supply chain, either upstream or downstream. And if companies like Siemens, for instance, or Volkswagen currently tell us that they want to be carbon neutral in 2025 or 2030, they talk about this topic here, their own manufacturing process, the last step of the manufacturing, and maybe also the electricity they buy. So what Elon Musk is doing, like with the carbon neutral car manufacturing, he puts some PV panels on his manufacturing plant. And then this is the 9.2% of the environmental impact. But I think we more and more have to talk about this, the supply chain impacts, and Cátia and Bruna, I think, very well referred to this very important topic. Here you see the upstream supply and the downstream processes. We really have to regard for all the processes in the supply chain, but currently we cannot do that because of missing data. Here you see the importance of that. Nowadays, we often talk about climate neutral manufacturing or climate neutral supply chains. And yes, climate impacts are important, but you see also all the other impacts that develop in the supply chain and that are relevant in the supply chain. We talked in the last presentation about water supply. That's also a big topic in supply chains. And we talked about social indicators, but maybe we also mainly talked about social benefits, like creating jobs, but we also have a lot of social challenges. And we have to really model and improve all these topics, the environmental topics and the social topics along the complete supply chain. So it is no longer enough just to look at our own production step. And why is it not enough? We also heard in the presentations a lot about that. We have increasing requirements. We have more and more legislation. I think the European Union is currently discussing this European supply chain law, which really regards or wants the manufacturer to be responsible for the complete supply chain. And depending on how the lobbying is going on, if we really have a sharp law in the future, it would mean that the brand manufacturer is responsible for the social impacts along the supply chain. So if there is something like a fire in Bangladesh in a company, the final producer would be responsible for that, and there would maybe even be the possibility to fight that out in at the European court. Yeah, that's really demanding and increasingly demanding on supply chains. Also a very important development that we've seen over the last maybe 7-8 years is that shareholders are more and more demanding regarding supply chains. We have the Carbon Disclosure Project. At the beginning, they started off asking the manufacturer about their carbon emissions, but now they are no longer happy with the producer telling them their own emissions. They really want to know about the supply chain risk. And we also heard from Cátia about risk assessment. It started off, CO2 emissions started off as a non-financial risk. So it was a risk that is too far in the future to be monetized. And currently it is more and more a financial risk. So CO2 is really seen as a financial risk in the supply chain, and shareholders want to see decreasing CO2 emissions. That's getting very important. We have these NGOs, Jessica talked about that have an important impact. And we have the customers. Some years ago, I was not too optimistic about customers because we are all customers and we all want to be sustainable. And then we go to the city and buy new stuff. But with this Fridays for Future development, I think there is a lot of development here. And the customers, especially young customers, really require answers about the products and the supply chains. We see some here, some topics that are important for what Cátia and Bruna talked about. We have social certification. We have the global reporting initiative. So we have a lot of social indicators, and we have a lot of environmental indicators, and the firms have to report about that. I here have 3 developments, and for me, it was long not so clear, but when I prepared my lecture this year, it became very clear to me that these are some of the big topics that we currently discuss as a society: circular economy, bio-based economy, climate neutral economy. We have European roadmaps that clearly state that as an economy, we want to develop in this direction. And in parallel, we have the same developments in supply chains. I think this is very important to see that the supply chain developments really is in line with what we want to achieve as a society. Just to give you a very, very short overview, circular economy, maybe you know all about recycling, remanufacturing. There was already a big development in the scientific literature in the 1990s and 2000 years already. So there's a lot of literature talking about these different end-of-life strategies like reuse of products and components, refurbishing of products, and recycling strategies. And the target in the end is to come up with a closed loop supply chain. Many, many years ago, I did my dissertation on these topics already. So when I look at the supply chains today, I have to say it is very important, especially regarding our resource availability. We have a lot of scientific literature on that, and still more is coming. We have a European strategy, we have recycling targets. I worked on the collection and recycling infrastructure for waste electronic and electrical equipment in Germany. And I can say we do that like we do everything in Germany. It's a very sophisticated system, and we have to write down targets on every single step of the system. We have a lot of recycling technologies, but if we look at the system at the current state, we have to say that we are not there yet. If we look for plastics, really only a very small part of plastics is really circulated. The rest is either still going to landfills or is like burned with some energy recovery. If we look for complex products like electrical products, there was a study 2 years ago that still 2/3 of the products vanish. Yeah, they vanish to Africa. They are illegally exported. So we have this very sophisticated recycling system. We have recycling targets, but still a lot of the material is just still vanishing. So we have to do still a lot of things here. We have a lot of discussion currently about bio-based economies and bio-based supply chains, which means that we use biomass not the biomass that can be used for food, but the biomass that's residues from forestry or so on. And we use that to produce new products. Maybe fuels is not the best product. Maybe we can have others. But what we see is when we come up with such a biofuel, with such a supply chain here, we see that it is even more complex. This is a biorefinery. We see that we can use now many different resources. We have a lot of technologies and we have a lot of potential products. We really, as a society, have to decide where and what for to use our scarce biomass, even if it's residues. So biomass is limited. It can only be part of the puzzle, but not the final solution. It needs a clear strategy for what we want to use our limited biomass. Developing. And Bruna talked about the different decision makers along the supply chain. I think here we have that even more because we now have different sectors integrated, like the agriculture sector. We have a lot of trades. We need societies. We need acceptance for what we want to use our biomass. So a lot of topics here that we need young scientists to work on. And then we have the third topics. It's climate neutral. I think we currently talk a lot about that, climate neutral society and climate neutral supply chains. We have these nice roadmaps, how we want to develop Europe into a climate neutral Europe, or Germany, a climate neutral Germany. And what we see here, these roadmaps really do backcasting, back calculations from 2050 on, and they are quite certain that if we use certain technologies, we can achieve climate neutrality. But if you look at the measures, we see here that we need, for instance, new measures in the steel supply chain. We need cement recycling. We need chemical recycling for plastics. And these are really ambitious measures and sometimes very, very high investment measures. So there's a lot of decisions that have to be taken here. Currently, the technologies are not competitive with the conventional ones. Our CO2 certificate prices are not high enough. We have very, very high investments. If you want to do OR models on a very long term until 2050, you have a lot of topics that you can tackle here. We need infrastructure. I think Jessica talked about infrastructure, water pipes, but we also need, in Europe, we might need hydrogen pipelines, CO2 pipelines. The technologies are often still in the pilot stage. And I think Bruna talked about that, the different stages of the supply chain. We have to be really careful that we do not shift the carbon intensive parts of the supply chain to other parts of the world and just keep the climate neutral end manufacturing in Europe. And this is about the different actors in the supply chain and different stages in the supply chain. So we need the system view to avoid carbon leakage, for instance. Yeah, and again, all these young scientists, you are needed. We need these models to come up with a climate neutral future. So to sum this up, I think there's not one concept. There's not one supply chain stage. Cátia and Bruna already talked about that. We have to regard for the complete system. Not one technology, it's not either economy or environment or social. It really we have to look at that in an integrated way. It's not about, I think, incremental changes. We currently really talk about big changes and transformation. And it's also not about a timeline of 10 years. We currently talk about very long timelines. Yeah? It's 2050, but it has to start now. Needs long-term policies and requires a transformation of product supply chains, business models. And that is what I wanted to tell you very shortly.
Thank you very much, Grit. We will want to see image like this one that you are showing to us. Very nice. You gave an excellent overview of the challenge that we have. So we may now start a little bit of discussion about what Bruna, Cátia, and Jessica share with us, and also your point of views on that. Grit, if you want to go ahead, and then we can open the floors also I will open the floor also to the other people.
Yeah. I think I want to start with one topic that Cátia and Bruna brought up, and there were already questions regarding that. It's the social assessment. I really liked your presentations, and I totally agree that we need this integrated assessment. But when I think about environmental assessment, I think I did my diploma thesis in this life cycle assessment, and already then there were discussions about how to come up with this impact assessment. Yeah? And when I look at the life cycle assessment journals, they still discuss these topics today, like about rating and midpoint or endpoint methods or whatever. So what we see here is that even for environmental indicators, it is very, very challenging to come up with integrated models that the society agrees upon. But when I think about social indicators, what I know is like the global reporting initiative that started off with 100 of social indicators. Nobody was really able to implement it, and now they boiled it down to a core assessment, but still that has tens of indicators. And Bruna, you talked about regional development and jobs. I think that's one part of the problem, but we also have a lot of other indicators like child labor, bad working conditions. Do you have an idea how to tackle that? It's about the quantification of the indicators, and second, it's about the rating in Bruna's case and the monetization in Cátia's case.
I don't know if Cátia wants to start or if I can.
You can start, Bruna, and I finalize with the monetization.
Yeah. So actually, this is a great question, Grit. Thank you. It's really something that we struggle with, and we discuss also within our group how to address this issue. There are the so-called social hotspots databases already available, which gather this information related to social risks in different parts of the world, according to the industry, according to they can actually give us a quantitative measure according to the number of hours worked and so on, which can, and it has already been used in some works, be integrated in this type of models. However, at least in my point of view, I still struggle with at least applying them in an optimization model, for example, since I think from the start, if you know there's a risk of having child labor in a specific country, for once, companies will not want to state that they know and that they still have their entities there, as they still want to have their entities installed there. So it would be something that it serves more as an assessment of the risks involved, and not, at least in my opinion, as something that we would base our decision on in an optimization model. It can be just to get to obtain an overall assessment, but I'm still not sure if that makes sense in this context. That's why in my PhD I chose this type of indicators, quantitative indicators that actually show a broader overview to decision makers in companies on how they can use their supply chains to benefit the society. So my answer is I don't know what's the best way to do it, but these are my views on the type of data that we have. Still, there's a lot of uncertainty. involved in the data. And it's always secondary and tertiary data that we are using normally, but it's still ongoing work.
Yeah, I think it's also a bit a topic about the system boundary. So if we have like a look at the European supply chain, then that's I think a very good indicator to look at regional development. If we have a global supply chain and we might have like shifts of certain processes to other countries, then we have to be a bit careful with the other social indicators, not to shift the environmental badly bad and the socially bad processes to countries that will no longer tackle about.
Our responsibility, right?
Yes.
Yeah, for sure. Yeah, I agree.
Do you want to add?
I just want to add that beyond that difficulty that we have considering the different types of social indicators, and as I want to translate them in a unit easily understandable for decision makers, it is extremely difficult. So that's my biggest worry now, is to understand how I can correlate the social indicators that are already difficult to model, to correlate with economic indicators, to translate them in a unit easily understandable for decision makers. So this is extremely difficult, but we are trying to do it.
Okay.
Maybe Jessica also can add something on that, Grit, because one of her thoughts when she developed the model was this, distance, yeah? How far they should travel. I think this is a very concrete social indicator, yeah?
Yeah.
That is really related to the well-being of the population. Jessica, can you share with us this concern of social equity, because it's what you are really looking there, and maybe some of your ideas could then import it to other more industrial supply chains?
Yeah, in fact, that was the standards from the WASH organization, that is not completely fair, in the sense that people, it's all in these standards, but we are talking about people that it's going from home to the water tap to carry then water to home. So it's not the same if you have to go up without the water and down carrying the water, or the other way around. So they measure as a distance, but it would be probably better, and the model would be completely the same, instead of using distance, using the work, measuring joules. So you have taken into account the distance, the way that you are carrying, and also the angle of displacement. So they use something that is simple and to be fair, but sometimes you are missing something else, but that it's difficult to take into account, because for the model, of course, you can directly change distance from joule, but to be able to compute the joules and to know that data, that is difficult to get. So sometimes even you are able to know how to measure, the real measure is difficult to get.
Jessica, I found it very great that you started off with this one objective, and then you developed the second one together with the people and the municipality. I think that's a very great success to come up with such developments in modeling. I don't know if you can answer me this question, but regarding your answer that they didn't implement our result, but they had some political solution, and our OR model was just used to calculate bring a comparison. That really remembered me on industrial applications of OR. I think there also happens a lot. And there we have these operations management people that calculate and work with data the whole day, but then you give them a model and they do not believe the model. Yeah, they believe their Excel sheet, they believe what they did during the last 20 years. And so it is very hard to implement OR models in industry. And you just told us that it is also hard to implement or these results in practice. Do you have an idea what could be done? Was the problem that the people did not understand the model, or was the problem that they had their political solution anyway and didn't care?
The thing is that there is always some political issues, like this is near the head of the village, or this is kind that are not measurable, and it's not fair, probably, I would say, that they want to make happy that people, even this is in detriment of the solution. Or that maybe they need, if there is some school or some hospital, we ensure that they have a water tap. That was also in the model. Special buildings with this kind, they have to have the water tap. But there was other buildings or other things that for the NGO was not important, but for political issues there were. So then they have to fight to arrive to a compromise.
Okay, but at least they did some fighting, so
they try.
Okay. You showed it for 2 communities. Is there a plan to use that also for other communities, rest of Nepal, or in other parts of the world? I think you always need these slopes to apply your model.
It can be extended. The difficult part is to obtain all the data that has to be done by satellite image, but it can be used for more.
I have more questions, but I think also the audience might want to ask questions. So I don't want to talk the whole time.
Yeah, I can ask to the audience if they want to raise some question, and then if not, we will continue. Paula, yes?
If I can ask Grit a question. So thank you for the lovely presentation, Grit, but within it you mentioned somewhere blockchain. I didn't quite get what would blockchain be offering to help sustainability in supply chains? What's its role?
There are currently developments that we have certain startups that integrate or that implement blockchain technology to gather environmental data and also social data. So just to increase transparency of the supply chain, because even in our transparent supply chain, like the food industry, we all have these scandals because something happens and we have no transparency. And that even more holds for complex supply chains, complex products. And with blockchain technology, they just try to increase transparency and come up with all the environmental data.
Thank you.
Anyone else wants to ask a question to anyone? No, it seems not. So maybe, Grit, you can continue.
Yes, if not, then I have a question to Cátia regarding this monetization. I think you're really brave using monetization of environmental and social impacts, but also environmental impacts, because what I saw in the literature and also in practice for many, many years, this topic was just neglected, because nobody wanted to monetize the 1 year of a life of a human or whatever. Nobody really dared to do that. And I saw that in the last, I think 5 years, things changed. We had this, I think, Novo Nordisk report who tried to monetize their externalities as a first report. But when I look into the data, we see a very large range of monetization factors. Like we have the Danish guidelines that come up with another monetization of 1 year of a human life than the true cost approach. So what I understood is that you use data from CIMA-Pro, is that right? Or,
yes.
Okay. And then I was a little bit surprised that you, as an uncertainty, you regarded the typical supply chain uncertainty, which is demand in supply chains. Wouldn't it be important to look at the uncertainty that come with these monetization factors? Because we have a factor of 3 or 4 or even more sometimes between the different monetization approaches.
Yeah. Yes, Grit. Yes, you're right. It could be interesting also to think a little bit about that. But in fact, when there are several monetization methods, several life cycle impact assessment methods that we could choose. But EPS, that was the method chosen in this work, has already the uncertainties clarified. So that was an advantage of this method compared with the other ones. But yes, you're right. In fact, monetization has always been a little bit ethically questionable. We know that when we think, for example, in life insurances, okay, that is a practical long time. But we thought that it would be interesting, as environmental approaches are difficult to understand for decision makers. Okay, well, maybe if the decision makers have a unit, a monetary unit that they are used to deal with, maybe they could understand a little bit more the impact that their supply chain can have in reality. So, and the numbers are scandalous. So the impact on environment is really worried. So that was the motivation for this work.
Okay, I totally agree that we need these approaches, and I really like that they are more and more applied, because many industrial decision makers only understand euros and dollars, and then we have to come up with this kind of evaluation.
Unfortunately, but yes.
But do you also think about approaches that regard for this uncertainty, like not the decision variable uncertainty, not the demand uncertainty, but the assessment uncertainty? How to model or to integrate that into your model?
I didn't think too much about that, because I used in this specific work the EPS. But that is an interesting thing to do for further works, especially now that I'm worried about the social component. That is a thing that I have to consider. Yes, that's too important.
Yeah, Grit, I think this is very important, the point that you raised. And I would say that Bruna can add something on that, because I also know that she has been looking into that. So Bruna, maybe you can add something on this point.
In terms of the environmental uncertainty?
Exactly.
Yes, so it was something that it made me nervous in applying these models, considering from the start, the data itself, when we use these secondary data sources, it's quite difficult to understand exactly what the boundaries were, as you were saying. And so it made sense for me to make an analysis on the uncertainty, not analyzing the uncertainty itself, because it's a source of uncertainty that we don't even really know how uncertain it is, again, because there are so many possibilities in gathering the data from the different sources and so on. And so one of the works that I showed you was focused really on the decisions that someone that chooses to use to use the LCA methodology within this type of models, optimization models, some of the decisions that they would have to take during the application of the model. And so even using CIMA-Pro, you have certain decisions that you need to take, select different options. And so that was also something that I tried to see what would be the impact in the supply chain decisions if I were to choose something other than what I chose initially. And in addition to that, so in all of the steps of the life cycle assessment methodology, what type of decisions could potentially influence the supply chain decisions being taken? And so basically using a very similar methodology to what I presented, also using the epsilon constraint method, I went to see how different the solutions would be, considering the uncertainty in the life cycle inventory steps. So when you collect the data itself, and also uncertainties related to, well, the method selection is the number one uncertainty that you have. The normalization step also influences significantly the results that you obtain, and that was the main conclusion of the work. And that's why it's important to really have a clear idea, clear understanding of the robustness of the life cycle impact assessment method and their normalization factors, which that was the main conclusion. So the normalization step is actually one of the things that mostly affects the overall supply chain decisions. But I actually think optimization models and the way that we in operational research address uncertainty is actually something quite valuable that can somehow complement life cycle assessment and trying to see, okay, so if this is not exactly this value, how different would the solution be? And so I think the combination of these two methodologies is quite useful in addressing this lack of data, basically.
Anna? Great, go ahead with maybe one last question.
Yes, maybe I have a question to Bruna, because you said, and it is completely right, that you need the system view, and you very well showed how you looked at the different processes along the supply chain. And with the system view, we can indicate like the hot spots, and then, but as soon as we want to change something, then it is still the decision of the decision makers. And you showed us that we have these different objectives. They might not be in line, they might be contradictory. And yeah, how do you handle this? Do you have like a disaggregation approach to the actors of the supply chain after you looked at your system?
That's a tough question. So you mean disaggregating perhaps through the type of objectives that we are
I think that the manufacturer has a different objective than the supplier, and in the end that might not result in your system results.
Yeah, well, yeah, that's so here we are assuming that even though we might have obviously different entities owned by different companies, we are looking for the global optimum. We have not yet, but that's something that we are working on now, is using game theory to address these power struggles between the involved players, but not yet. It's not moved to that stage yet, but it's something that obviously makes sense. And I think importantly, it's very important to show the benefits of this global optimization compared to the local optimization results. And starting from there, then work on the contract deals, I'd say.
Yeah.
Okay, we are almost reaching the end. If you allow me, Grit, I would ask to each one of our young OR women, if they want to send a message on this area, what you would suggest to newcomers? Maybe I will start by Jessica. Jessica, if someone comes to you, a PhD student, and say, I want to work in this area, what should I do? What you would like to see her or him addressing? What suggestion you will give?
I probably would say that have fun in the way to do it, because our job is interesting. We can solve problems that have a lot of impact in real life, but in the PhD time, I would say also have fun.
Great, that's very good. Bruna.
Yeah, so I think I would say embrace the chaos and embrace the fact that you cannot solve everything, and try to focus on the task that you have at that moment, and understand what the potential impact is of that small task that you're doing at that time.
Thanks, Bruna. Cátia, you are the youngest one in terms of research.
I will mix the answers.
You would say, finish the PhD.
Yes, I think that, of course, we have to like what we do, and we should always think that our actions, our work could really impact on something. So if we can change a little bit of our impact on society, I think that would be an excellent work.
Okay, now Grit, what advice you will give to everyone so that we can just wrap up?
I think a dissertation is very, very hard work. So if I talk with potential candidates, I always tell them this is 4 years of very, very hard work. So you should be really sure that you want to do it. And then you should really do what is important to you. And if it is like such an important topic like sustainability, and you want to have an impact and want to have a contribution, then you will finally finish a very good dissertation, because it is about intrinsic motivation. And I think this is the most important thing before you start a dissertation.
Yeah, definitely. And adding what Jessica said, do it with fun. I think it's a good. Okay, we are just on time. So first of all, I want to thank Grit for the availability to be here to give us our understanding of the future, and also discuss with Bruna, Cátia, and Jessica these points. It was really very interesting. I want to thank all the people that have been joining us, the ones that are not already here, but the ones that keep to the end. Thank you very much for being here. And I also want to thank finally to Bruna, Cátia, and Jessica for their work, their contribution as young women using OR to solve very, very interesting problems. And I wish you, and we will wish you all the best in your future. Continue in the line that you have been starting, and for sure you, in 10 years time, you will be even much better than you are now, because you are already better, very good one. So thank you very much for all the work. I will finalize by recalling that we will have a Christmas webinar, and then we will have all the details in the webpage, and also Nuncia will spread around the word. So thank you very much, and be happy, and let's see COVID out, joy up. Okay,
that was wonderful. Before we close, if people want to turn on their cameras, if there are people there, we'll get one last screenshot for our newsletter. But thank you, Ana, Grit, and the speakers were all fantastic. I really enjoyed it. I learned so much today.
I also want to thank the speakers very much. I really enjoyed that, and I hope to see you all at the conference, like not far from now.
Yes. let's see, at least in Finland, yeah, hopefully. Okay.
Thank you, everyone. Bye-bye.
Thank you.
Bye-bye.
very
See
much.
you 20s. Bye-bye
Bye.
then. Bye.